You see me? Bam, turn the volume down. All right, Mr. Vickers, today we're going to do some EKG interpretation using Dubin's method, simplified into Dubin's 5 steps. Shall we begin?
Sounds good, dude. Let's lay it on me.
You're getting it laid right here. Do you see this EKG in your screen, Mr. Vickers?
I do.
All right. This is what you call a 12-lead EKG. For all purpose for this, says where you see C1 through 6, we're going to act like those are V1 through 6, okay?
Sounds good.
All right. So the first thing we're going to start, there's 5 steps of Dubin's method. Step 1 is rate. Step 2 is rhythm. 3 is axis deviation. 4 is hypertrophy. We're going to focus on left ventricular hypertrophy. And number 5 is we're going to look for ST depression or elevation, inverted T waves or Q waves to show ischemia, injury, or infarct. So,
I have a question. Time out.
yes.
So are you saying that step 3 is you're determining the axis, or you're specifically have an EKG here with axis deviation on it?
I am in step 3. We were going to determine whether the axis is normal, whether it's there's a left axis deviation or a right axis deviation. We're going to keep it simple, okay, Mr. Vickers?
Great, buddy.
All right. Does that answer your question?
It answers it above and beyond my expectations.
Very nice. Let's proceed. Number 1, rate. So, Mr. Vickers, have you ever counted the rate on an EKG?
In this setting, I'm going to say no.
Okay. Well, here's a real simple rule. Each box. Well, actually, let me backtrack. You can count the boxes, and they count like this: 300, 150, 100, 75, 60, and so on. So you're going to count the boxes in between these QRS peaks, and we're going to determine approximately what the rate is. You ready for this? Check out lead number 1, which is a very nice example because that QRS is right on the line, correct? We're going to count boxes. So let's count with me. We have 300 in the first box, 100, 150, 100, 75, then 60. So it falls in between 75 and 60, a little closer to the 75. So we'll go with 70. What do you think? That sounds good, doesn't it? So we have a rate here of 70. All right, so next, number 2 on the list is rhythm. So we're going to try to determine if this is a regular or irregular rhythm. So first thing we want to look at to see is there a P for every QRS? And so looking at this EKG, it appears there is 1 P for every QRS. And on top of that, the rate appears regular. The distance between each QRS looks very, very uniform. Is that correct?
To my eyes, it also looks very regular.
Very regular, correct? But also, we want to make sure the PR interval is less than 0.2 seconds. Do you see these PR? The PR interval appears to be less than 0.2 seconds. Can you see that? And we also have a QRS that is narrow, meaning less than 0.12 seconds. That appears to be narrow QRSs, wouldn't you say? All right, so this right here will be a regular rhythm. So we have a regular rhythm with a rate of 70 so far, okay? Number 3 on the list, we're going to determine if there's any axis deviation. So we're going to look at lead 1 and AVF. And we're going to look at if the QRS is predominantly positive, meaning upward, or predominantly negative, and we'll call that downward deflection or negative deflection. And in lead 1, it is obvious it's very positive. And in lead AVF, it is obvious it is positive. So if there's 2 positives, we're going to determine that there's no axis deviation. Normal axis deviation, correct?
I would say that's incorrect. I would say that there's no such thing as normal axis deviation.
And that, you were so right. This is a normal. This is a normal axis. Sorry for the confusion. All right, let's move on to number 4. Okay, step number 4, we're going to, and for all intents and purposes for this, we're going to just look at left ventricular hypertrophy, okay? So we're going to look at V1 and V5, and we're going to count the S deflection in V1 and the R deflection in V5. We're going to count the amount of large boxes that they I guess, consume. And if that is less than 7 total boxes when you add them together, then we are going to assume that is not left ventricular hypertrophy, or there's no evidence of left ventricular hypertrophy. Sound good? So in V1, which is going to be C1 on your screen, if you start counting, it's approximately 2.5 to 3 boxes. We'll just keep that in mind. So we'll go higher and say 3. So then let's count V5, which is going to be C5 on your screen, and here it is also about 2.5 boxes. So regardless if V1's 2.5 or 3, and C5 is 2.5 or 3, it's still less than 7 boxes. So we're going to determine there is no left ventricular hypertrophy on this EKG. Wouldn't you say that's correct? Okay. All right. So moving on to step number 5, and our final step, we're going to look for ST segment depression and or elevation in any of these leads, as well as inverted T waves and the presence of any Q waves. So we'll just kind of start from lead 1 and just kind of work our way from lead 1, 2, and so on. And so looking at this, there doesn't appear to be any ST depression or elevation in leads 1, 2, or 3, as well as AVR, AVL, AVF, or any of our chest leads. There's no depression or elevation. Do you see that? Okay. And while looking at these, do you see any presence of inverted T waves, meaning if T waves are not, let's see, in the same direction as the QRS? I don't either. So we'll say there's no presence of inverted T waves. Also, do you see a presence of any Q waves in any of these leads, meaning a downward deflection before your QRS? I don't see any Q waves either. So we're going to determine this as being there's no presence of any of these things. So we'll say there's no evidence of any kind of ischemia or infarction in this EKG. So with that being said, when we add up all these steps, we'll say that this is a normal, regular rhythm with a rate of 70, with normal with normal axis, no presence of left ventricular hypertrophy, and no myocardial ischemia, injury, or infarction. Does that sound good to you, Mr. Vickers? All right.
All right, dude, now you just have to